Greetings to all. My name is Huzefa Haider and I'm the final year student of University of Engineering and Technology Peshawar in the Department of Mechatronics Engineering. In my 4 years of graduation, I've done a lot of researches and I've done a lot of projects which are at a very small level. This is my first project that is at a mega scale, and I'm doing this project with my group members with Ms. Aksai Naam and Mr. Muhammad Mujib. In this project, we are helped and we are supervised by our respected professor, Dr. Anam Abid. And this project was started in somewhere between 20th and 25th May of 2024. This demo video is a short and a very summarized form of our progress. So I will cover some topics that are quite comprehensive. I'll shorten them up, and it will be a very short video so that every point is discussed. From the title, it is quite evident and quite visible that we are working on deep learning model making, and we will work on the mechanical design, that is conveyor belts, and the whole idea is to do quality inspection through deep learning models. Obviously, the AI factor is included in this project. So, first of all, we will cover the mechanical design. The mechanical design of our project will be displayed here. This is a CAD model of our project. It is in a soft form, obviously. So you can see the 3D image of this whole idea of how we will develop the model and how we will implement that model over conveyor belt. This is a very initial model that we have made. Now, for our product of inspection, we have chosen PCBs. The PCBs that we have chosen will be constructed by us, will be fabricated by us. So the design of the PCBs and the whole dimensions of the PCBs will be set according to us, and they will be a very standard PCBs of 2 x 2 inches. Now those PCBs will be etched. The design of those PCBs will be etched on this plate. This is a copper plate, cladded plate. So the dimensions of this is according to our PCBs. Our PCBs will be about 2 x 2 inches. So this plate will carry about 6 PCBs designs. Now the PCB design is shown here. You can see it. We've covered the section of designing. Now let's move on to the most important section of our project, that is the deep learning model. The deep learning model is actually trained by one of the data set was trained, and we saw the results so far. The whole aim of our project is to make our customized PCBs and make our customized data set according to the PCBs, and then create that model according to that data set that we have made. So for training purposes, we have trained the model, and we've seen the results. They were quite accurate, they were quite positive, and we are quite motivated to the next step of our project, that is making our own data set. Right now, I'll show you the screen recording of the video that has been done by my group mate. The objective of our project is to efficiently detect defects in printed circuit boards using deep learning. For this purpose, we chose the YOLO V5 model, known for its speed and accuracy in object detection. We utilized an available dataset of labeled images having 6 classes of PCB defects. We used Python and trained the model in deep Google Colab for implementation, which provided the computational resources needed for deep learning tasks. After setting up the YOLO V5 training environment, we trained the model by passing batches of images through the network. During training, YOLO V5 adjusted its parameters to predict bounding boxes and classify defects accurately. After training, we evaluated the model using validation data, where it demonstrated promising results by effectively identifying defects. We evaluated the model's performance through metrics like confusion matrix, precision, and recall curve. The trained model achieved an accuracy of about 94% in detecting PCB defects.